Alright, so today we're doing surface area and volume of spheres, and honestly guys, I really like spheres. They're just really simple to do. They're just very easy. Okay, so let's check it out. So a sphere is the set of all points in space that are a given distance from a given point called the center. So like imagine you have a center point and then all the points in space that are, let's say, 5 centimeters away from it together create the sphere, essentially a ball. So a radius is a segment from the center to a point on the sphere. So the radius is anywhere from the center to a point on the sphere. So we see it right here. All right, so a chord of the sphere is a segment whose endpoints are on the sphere. So for example, if you had endpoints on the sphere like that, then that can be a chord. Chords are on spheres also, okay? And then obviously the diameter is a chord because it goes from an edge of the circle to another edge of the outer edge of the sphere. And it is a chord that contains the center. So if you are talking about the diameter, then that would be from one edge of the circle to the other edge of the circle, but going through the center like that. Now, honestly, we just need the radius for all of our formulas, so that's pretty awesome. So let's go check this out. So first, we're going to do volume. So volume of a sphere, the formula is 4/3 pi r cubed. And obviously r is the radius. So that's the only thing you have to plug in, so these are really easy. So the radius is 2. It says find the volume. So we're going to do 4/3 pi times 2 cubed. Now let's talk about if they want it in exact form, like leave in terms of pi. If they say that, okay? They meaning like the worksheet or whatever. So if they say that, you do everything except the pi. So like you do the 4/3 times 2 to the third power. Okay, so let me just use a calculator here. All right, 2 to the third power. All right, and so I get, if I leave it in a fraction, 32/3 pi. So that's the exact amount. But if we want to approximate it, then we can just type it in including the pi. So 4/3 times pi times 8, which is 2/3. I just did 8. It's 33.51. And that is a volume, so it's centimeters cubed. Volume is always whatever the units are cubed. Okay, now on this one, it says find the radius, so we're working backwards. We know the volume. So whenever that happens, it's always just using the formula, plugging in what you know. The volume is 28 pi, and it equals 4/3 pi r to the third. Now let's talk about how you would move this. Personally, I would start with moving the 4/3, so I times by 3/4. The reciprocal, because what that's going to do is you'll have 4/4, which is 1, and 3/3 is 1. Okay, so now let's go ahead and use our calculator. I'm just going to do the 3/4 times the 288. All right, and so that becomes 216, and we still have the pi. All right, equals pi r cubed. So now if we divide by pi to get the r by itself, we have just 216. All right, so 216 equals r to the third. So to get rid of a third power, you need to use a cube root. That cancels out a cubed power. Okay, so let me go ahead and show you where this is on your calculator. I'm going to pause the video and load my calculator just 1 second. Okay, so there's several different ways to do this. First, you can hit the math button, and then if you see the fourth one down, that is the cubed root. So you can hit that and then do the cube root of 216. Okay, so our answer is 6. Let me go ahead and show you a few different other ways though. Okay, you can also hit the math button, and this fifth one down is x root. So you can do any amount of root, but you need to put the 3 first, then the math button, and then the x root. It tells it you want the cube root, and it will sometimes fill it in. On older calculators, it may leave like kind of a weird symbol there, but it'll still come out correctly. Okay, another place you can get to this is we've been using F1 up here above the y equals to get to our fraction button. F2 is going to get to us some quick math type things. We can hit alpha, and then the window button to get F2. And so here you can see on number 6, there is our cube root. So like if we hit number 6 right there, then we can fill in that we want a cube root and then go inside of 216. Now last but not least, the other way you can do it is a cube root is the same as a 1/3 power. So you can do 216 and then do the caret button and then do to the 1/3 power like that. So those are all different ways you can do this. You just pick one that works for you and stick with it. Okay, so let's look at surface area of a sphere. So the surface area of a sphere, the formula is 4 pi r squared. So once again, really easy because you just need the radius. So on this example, it says that our radius is 3/2. You can put it in as 3/2, or if you want, you can put it in as 1.5. So remember, if you want the exact area you leave in terms of pi, that means you do everything but the pi button. So you do 4 times 3/2 squared. Okay, and that gets me 9 pi. That is the exact area. But now if you want the approximate rounded answer, it says round to something, then you can type it in including the pi. So you could just type in 9 times pi, but if you haven't already done that, just type in 4 times pi times 3/2 squared. All right, and I get 28.27. And we are in centimeters, and because it's an area, it's a surface area, we put squared. So this one gives us the surface area, and it wants us to find the radius, so we're working backwards. So the surface area is 24 pi equals 4 pi r squared. So to get r by itself, I would divide by 4 pi. What you do to one side, you must do the other. The pi's cancel out. 24 divided by 4 is 6. And then to get r by itself, you square root to get rid of squared. And so r equals the square root of 6, or if they want a decimal answer, of course you can go ahead and you can type that into your calculator. So let me see what I get. Square root of 6 is roughly 2.45. So spheres are actually super easy.